Good day, my amiable viewers. You are welcome back to class. And my name still remains Israel Egwai. For those of you that have been subscribing to this channel, thank you very much. And equally those of you that have been sharing it, I'm indeed highly appreciative. But for those of you that have not started, please, kindly help to share it. Because more subscription encourages us in this channel. Now, some of you wrote in your comment section that you love the way I explained the titration procedures in one of our videos. He said, please, I should try and use any of the WAEC past question as an example. That is why we are here today. The example we are going to use is WAEC 2021. So you listen very well and try to follow the whole procedures. But remember, other WAEC questions that will be given is the same pattern they use. So if you understand this, another WAEC practical videos we are going to be putting, it will be very easy for you when you come across any question in WAEC. Now, like we said before, this one is the burette attached. This is the burette containing, let me unclip it. This is the burette. This is the retor stand and clamp. We've already described it in our previous video. It's used to measure the volume of acid. This one is the pipette. This one is calibrated from 0 to 50. This one is the pipette. 25 cm cube is what I'm going to use. Some schools use 20 cm cube, but here I'm going to use 25 cm cube. Because in the school I work, we normally use 25 cm cube. Then this is solution B. That's how it will be given to you in your WAEC. Solution B means base. B means base. While this one is solution A. A means acid. Then this is the funnel that I used to transfer the acid into the burette. So let's get started. Like I told you before, to start, you have to rinse. Even if you wash it with soap or anything, you must rinse with small quantity of the acid you are going to use. That is one precaution. But it doesn't stop there. You say also rinse the pipette with the given quantity. That is, rinse the burette is a small quantity of the acid to be used, and the pipette with a small quantity of the base solution. Then you rinse this one with a water which makes it neutral. We have already washed and we have already rinsed. But remember, don't indicate wash. It's only rinse that WAEC accepts. So let's add the solution. Let's reduce it. It's too high. Continue to add it till it gets to the 0 mark. Okay. It's add at the 0 mark, but it is not at 0. You have to readjust it to remove the air bubbles. Okay, just very straightforward. So I'll now refill it because it has reduced. I'll refill it now. We went beyond it, so I'll readjust it again. Remember, this is the acid solution. Okay, it's at 0 mark now. Then remember, this one must be neutral. Rinse with water. This pipette, I've already rinsed it with some quantity of the base to be used. Remember, solution B means base. So it has got to the mark, minuscule mark. So I now pour everything inside, allow it to drip through, to flow through inside into the conical flask. This paper can be any paper or white tie. You cannot get a white tie, a piece of paper, so long as it's white, it's okay. It tells you to know the color change. Immediately there is a color change. That's the point at which a given volume of acid neutralizes a given volume of base, indicated by the color change. It's flowing. not too fast, but you allow it to drain through on its own. You must not blow it. But if you blow it, some saliva may add to it and to give you a wrong value. Moreover, the last drop, which is supposed to remain according to manufacturer's calibration, you see, it can never go. There's always a last drop. It has been calibrated in such a way that that last drop must always be there. Then this one is the indicator. The indicator is ethyl orange. Ethyl orange. You see it. You put 2 drops, not more than 2. There's some authorities say you can put 1, but I prefer using 2 drops. So you can see it is yellow in color. Then let us carry out the titration. Before we carry out titration, let's try something. Let's draw the table. First of all, use volume of pipette. .5.000 is okay. Then draw titration table. You follow my channel, you don't have problem with your chemistry. This is final burette reading. Initial buretting. There you have volume, acid, use. Put it like that. Here you have rough or first. But you must write the unit. If you don't put CMQ, they mark it wrong. You lose marks. First, CMQ. Second, CMQ. So this is how you write it. Remember, we started from 0. 0.00. You can just write all of them. 00. I already showed you, if the acid is not enough, there's a way you write the value. So let's carry out the titration. Remember, the color is yellow. You are going to carry out 3 times. As you are pouring in the acid, you don't need to watch up, just be looking at your solution. Once you see the color change, you stop. You see it has changed to orange, from yellow to orange. This is the orange color from yellow to orange. So what we now do, we now take the reading, 24.3. Final 24.30. If you use 24.3, listen very well. 24.3, you start losing 1 marks. Supposed to be 2 decimal places. So let's refill it again. Since we still have enough acid, we can refill it again. Okay. We readjust it to get to 0 mark. Okay. So we will now discard this. We don't need this again. We throw it off. We will rinse it with water. And rinse it 2 times. Rinse it again. It must be rinsed with water all the time. Since we have already rinsed the pipette, we don't need to rinse it a second time. Since we are using the same solution, we now put it again and pipette. Okay. Remember, you must, another precaution I gave you in the previous class, you must remove air bubbles from both burette and pipette. If you say only burette, they don't mark for you. You must always indicate the 2. Rinse the burette and the pipette with the solutions to be put in them, or rinse the burette with the acid and to use in it, rinse the pipette with the base to be used in it, or alkali to be used in it. Then rinse the conical flask with water. 3. Remove air bubbles from both burette and pipette. Then you can say use a white tie or white paper. It's accepted. Avoid error due to parallax. See the way I'm looking at it once, not your eye will be moving up and down. That's parallax error. Those of you that offer physics will be able to know what is parallax error easily. You can see there's still one little one drop. You must not blow it. I won't give you a reason for that. The next thing you have to do is to add the indicator again. Remember, 2 drops of indicator. You can see it is yellow. Then we start our titration as before. You know what you are doing, it will be easy to change. You see it has changed color again to orange. So we put it somewhere and we take our reading. Wow, exactly 24. So it is 24.00, 2 decimal places. Let's do the last one. We rinse again with clean water. About 2 times we do. We can refill it for the last time. It takes time to do this titration, but make sure you don't miss any step. Good. Let me adjust it. Okay, it's a 0 mark. Then you now carry out, draw this one again. Let's see. Good. I have to release it inside again. This is the last titration we are going to be able to do. 3 is enough. No need to be doing 5, 10. Just do 3. When they are marking WAEC, what they normally use is 2 concordant values. Concordant values means values that don't differ by plus or minus 0.2. Go to my first channel, my first video on titration. How to carry out accurate titration. That's the heading. You will see how to carry out titration. Make sure you follow the precautions, everything in detail. Understand it very well. You don't have any single challenge when you are carrying out your practical work. As usual, there's still 1 drop. So we carry out the titration, the last one, before we start the calculation. Don't be too slow because you just have 2 hours for the whole work. 1, 2. You see it again, the solution is yellow in color. Then we start the work. Whenever we still add acid, I will fill it. If it's not up to, if there's no acid again, check my first video, see how to calculate it, where you start from, and how to write your values. It has changed to orange again. You can see it has changed to orange color. Orange color. This is the color, orange color. So we stop there. Then the next thing is to take to see the value. take the readings, 24.00. So the third one is 24.00. You see it. The next thing you are going to do is to subtract. You subtract this 24.00, 24.00, 24.30. You can see that this one is more than plus or minus 0.2. Plus or minus 0.2, so we cannot use it. Even if you strike it, doesn't matter. But we are going to take these two. These are the two components that will earn us for 4 marks. This is 1 mark, this is 4 marks, making 8 marks. So it's a very easy thing to get. Say average volume of acid used equals, let's go up, 24.00 plus 24.00 over 2. You have already said your values are 24.0, so don't come and use here 24. You must indicate 24.00 so that you have 48.00 over 2 give you 24.00 cm³. You see it? So this one is 2 marks, making 1 plus 8, 9 plus 2, 11, 11 free marks. Then before you go to the calculation, A is a solution containing 2.03 gram of HCl per 500 cm³ of solution. You see it? I said when you have this, when some students see 500 or 250, they know they are already getting 2 marks bonus because they have to standardize by converting to 1 dm³, 2 marks. Solution B contains this mole per dm³ solution of alkali. Put it into the burette and titrate it. We are using this because this is the one used in my school and this is the one I use in this class. Some schools use this. That's why you must indicate it. That's where your mark starts, and this is just 1 mark. Portions using methyl orange as indicator. Tabulate your burette reading and calculate the average volume of acid used. From your results, you have already tabulated it and have the average volume of acid used. Calculate the concentration of A in mole per dm³. If you look at it, look at your solution, you have solution A contains 2.03 gram of HCl per 500 cm³. Convert this one to dm³. Use this directly, they will mark everything wrong. So you now have, you say, that's Roman figure 1, 500 cm³ of A contains 2.03 gram. Therefore, 1000 cm³ contain X. 1000 means 1 dm³. Everything we are using here is calculated based on dm³. So you now say S times 500 cm³ equals 2.03 gram times 1000 cm³. S will be 2.03 gram times 1000 cm³ over 500 cm³. cm³ cancel this here 1, this here 2. Become 2.03 gram times 2. Give you 4.06 gram per dm³. You see it? That's what we now have, 4.06 gram per dm³. The next thing now is the question says calculate the concentration of A in mole per dm³. So we are going to clean this side so that we can have enough space to use. So you say concentration in moles per dm³ equals, you can see the question again, concentration of A in mole per dm³ equals concentration in gram per dm³ over molar mass. Remember the name of the acid is HCl. HCl. So, and this one we already calculated at 4.06 over molar mass. 1 plus 35.5. This gives you 4.06 over 36.5. Let's carry out the calculation and see what it gives us. .06 divided by 36.5 give you 0.11123. 0.11123. This is approximately 0.111 mole per dm cube. So that is that on the first calculation. Concentration of A in mole per day. Second one, number of moles of acid in the average titer. Number of moles. Remember this, the average titer 24.0 cm cube. Number of moles of acid. Then what you do from this, I think that's Roman figure 2. Roman figure 2, you say 0.111 mole in 1000 cm cube. Remember, dm cube means 1000 cm cube. Therefore, i.e. 1000 cm cube contains 0.111 mole. Therefore, 24.0 cm cube, I'm quoting it exactly, you call it correct substitution, equals S. Now become S times 1000 cm cube equals 0.111 mole times 24.00. X equals 0.111 mole cm cube times 24.00 cm cube over 1000 cm cube. Cm cube cancel cm cube. Let's see what we have. 0.111 times 24.00 give you, divide by 1000, give you 2.664 times 10 to the power minus 3. 2.664 times 10 to the power minus 3. Let's erase the other side and see how it goes. You don't even need this side again. You don't need it. So automatically this one becomes 0.0026. 0.002664, which is 0.00266 mole. You see it, you count 1, 2, 3. Okay, it's okay. Then the other one, number of moles of alkali in the volume of B pipetted. That's Roman figure 3. Number of moles of alkali. And remember the volume of B pipetted. The volume of B we had was 25 cm cube. Volume of B, CB, is 25.00 cm cube. And here you have 0.12 mole per dm cube. 1000 cm cube equals 0.12 mole. 25 cm cube equals X. Cross multiply. S times 1000 cm cube equals 25 times cm cube times 0.12 mole. S equals 25 cm cube times 0.12 mole over 1000 cm cube. Cm cube cancel cm cube. Let's see what we have. 25 times 0.12 give you, divide by 1000, give you 3.0 times 10 to the power of 3. 3.0 times 10 to the power minus 3 give you 0.0033, which is approximately 0.00300 mole. 3 significant figures. Remember, you must maintain 3 significant figures throughout. That's that. Then the last one, mole ratio of acid to base in the reaction. Let's see. Mole ratio of acid to base. Remember, that of acid is this. Mole ratio of acid to base in the reaction. Acid, base ratio. Acid is value of acid 0.00266 mole. Ratio base 0.00300 mole. So to find the mole ratio, divide by the smallest based on empirical formula method. Now becomes 0.00300 266 over 0.00266. Ratio, sorry, there's no ratio here yet. Ratio, it's already when you divide by the smallest, you can have a ratio. 0.00300 over 0.00266. This one automatically give us one ratio. Let's see what the other one will give us. 0.00300 divided by 0.00266. I hope it's 266. Yes. Give you 1.1278. 1.1278. Approximately 1:1. So this is the mole ratio. Mole ratio of acid to base in the reaction. Viewers, thank you very much. This is a very simple way of calculating it. Remember, the year this question was given in the year 2021. As I told you in the other video, they always alternate it. Even if they don't bring all the questions, they may pick from inside and miss other ones with it and add it to your question. So if you know this, there's no other place they bring questions from. So with time, we'll continue to do many of them. Some videos we are going to be looking at later, we will change the indicator. Instead of using material range, we look for the past question that they use phenolphthalein, so that whichever way they come, you're able to handle it. And don't forget, you can only know this if you are watching my video regularly. Please kindly subscribe, share it to your friends, and like. Thank you very much. God bless you. Concentration in moles per dm cube equals, you can see the question again, concentration of A in mole per dm cube equals concentration in gram per dm cube over molar mass. Remember, the name of the acid is HCl. HCl. So, and this one we already calculated at 4.06. 4.06 over molar mass 1 plus 35.5. This gives you 4.06 over 36.5. Let's carry out the calculation and see what it gives us. (4.06) divided by 36.5 give you 0.11123. 0.11123. This is approximately 0.111 mole per dm cube. So that is that on the first calculation. Concentration of A in mole per D. Second one, number of moles of acid in the average titer. Number of moles. Remember, this is the average titer, 24.0 cm3. Number of moles of acid. Then what you do from this, I think that's Roman figure 2. Roman figure 2, you say 0.111 mole in 1000 cm3. Remember, dm3 means 1000 cm3. Therefore, i.e., 1000 cm3 contains 0.111 mole. Therefore, 24.0 cm3, I'm quoting it exactly, call it correct substitution, equals S. Now become S times 1000 cm3 equals 0.111 mole times 24.00. X equals 0.111 mole cm3 times 24.00 cm3 over 1000 cm3. cm3 cancel cm3. Let's see what we have. 0.111 times 24.00 give you, divide by 1000, give you 2.664 times 10 to the power minus 3. 2.664 times 10 to the power minus 3. Let's erase the other side and see how it goes. You don't even need this side again. You don't need it. So automatically this one becomes 0.0026, 0.00262664, which is 0.00266 mole. You see it? You count 1, 2, 3. Okay, it's okay. Then the other one, number of moles of alkali in the volume of B pipetted. That's Roman figure 3. Number of moles of alkali. And remember the volume of B pipetted. The volume of B we had was 25 cm cube. Volume of B, CB, is 25.00 cm cube. And here you have 0.12 mole per gm cube. 1000 cm cube equals 0.12 mole. 25 cm cube equals x. Cross multiply. S times 1000 cm cube equals 25 times cm cube times 0.12 mole. S equals 25 cm cube times 0.12 mole over 1000 cm cube. Cm cube cancels cm cube. Let's see what we have. 25 times 0.12 give you, divide by 1000, give you 3.0 times 10 to the power of 3. 3.0 times 10 to the power minus 3 give you 0.00333, which is approximately 0.00300 mole. 3 significant figures. Remember, you must maintain 3 significant figures throughout. That's that. Then the last one, mole ratio of acid to base in the reaction. Let's see. Mole ratio of acid to base. Remember, that of acid is this. Mole ratio of acid to base in the reaction. Acid, base ratio. Acid is value of acid 0.00266 mole. Ratio base 0.00300 mole. So to find the mole ratio, divide by the smallest based on the empirical formula method. Now becomes 0.00266 over 0.00266. Ratio, sorry, there's no ratio here yet. Ratio, it's already when you divide by the smallest, you can have a ratio 0.00300 over 0.00266. This one automatically give us one ratio. Let's see what the other one will give us. 0.00300 divided by 0.00266. I hope it's 266. Yes. Give you 1.1278. 1.1278. Approximately 1:1. So this is the mole ratio. Mole ratio of acid to base in the reaction. Viewers, thank you very much. This is a very simple way of calculating it. Remember, the year this question was given in the year 2021. As I told you in the other video, they always alternate it. Even if they don't bring all the questions, they may pick from inside and miss other ones with it and add it to your question. So if you know this, there's no other place they bring questions from. So with time, we'll continue to do many of them. Some videos we are going to be looking at later, we will change the indicator. Instead of using material range, we look for the past question that they use phenolphthalein, so that whichever way they come, you're able to handle it. And don't forget, you can only know this if you are watching my video regularly. Please kindly subscribe, share it to your friends, and like. Thank you very much. God bless you.